construction of this centroid, which is the point of concurrency for the medians. The medians, if you recall, connect from a vertex to the midpoint of the side opposite. And the way you do this construction is you first have to find the midpoint. The way you do that is by constructing the perpendicular bisector. The only difference is this time we don't actually have to draw the entire perpendicular bisector. All we have to do is indicate where the midpoint of the segment is. So I'm going to pivot on A and swing to C. I'm going to pivot on C, swing an arc to A. And I did not make my first arcs big enough, so I'm going to have to go back over to A, swing bigger arcs. Okay, now, of this line segment, all I really need is the midpoint. So I can draw the entire line segment if I like, but what I really need is the midpoint. So what I care about here is this point right there. Okay, so I'm going to pivot from B and go to that midpoint. Okay, that's my median. So what I'm going to do for simplicity's sake is I'm going to go ahead and get rid of the line that's the perpendicular bisector because we've already marked the midpoint. So I've gone from B to my midpoint. This is my centroid. Now what I'm going to do is I'm going to do the perpendicular bisector for line AB. I'm going to come pivot, throw that away. I'm going to come pivot on A and swing an arc. It's more than halfway to B. Swing above and below the line. Then I'm going to come to B. I'm going to swing an arc above and below the line there. Now I'm going to connect. I'm going to show where that line is. The perpendicular bisector is there. But the only point I really care about is the midpoint. So I'm going to take that line away so I don't have too many lines in here. And I'm going to connect from C to that midpoint. Next part of the construction is going to do the perpendicular bisector to BC to find the midpoint. So I'm going to come pivot on B. I'm going to swing an arc. It's clearly more than halfway towards C. Then I'm going to pivot on C and swing that arc back toward B. I'm going to use that line to find the midpoint. All I care about is the midpoint. So I'm going to highlight the midpoint. I'm going to get rid of that line. Now I'm going to connect from A to that midpoint. And I'm going to have a point of concurrency. Okay, so I have a point of concurrency. It doesn't matter, this is an obtuse triangle. It doesn't matter if your triangle is obtuse or acute. It's going to always land inside. And what you're going to find is if you measure these segment lengths, you're going to find, I'm going to call that point X, and I'm going to call this P, that O, and that Q. You're going to find that from A to X is going to be equal to 2 times x to O. And you're going to find that from B to X, it's going to be 2 times X to P. The other thing that you'll see, since they're cut at a 2-to-1 ratio, is the length of BP is going to be equal to, obviously, Bx plus Xp, but Bx is 2/3 of BP, and Xp is 1/3 of the length of the whole median.